All right, hi again. Today we're going to be talking about how to solve the quadratic equation using the square root method. And remember, when we say the word quadratic equation, the word quadratic means that we're talking about an equation that is to the highest polynomial order is to the second power, which means I'm going to have something with x squared. Now, this is the best method whenever the quadratic equation only contains the x squared term. So I'm just going to write it down. Fix the camera. All right, so this is the best method whenever the quadratic equation contains x squared and a constant, which means there implies no presence of any x term. All right, so or any x raised to the first power. So why do we find, what does it mean when we say we need to find x? Finding the value of x, so when we say we're solving the quadratic equation, is used when we are asked to find the x-intercept of the function. And as we know, when we say the word x-intercept, we automatically know that y is 0. What do we call the x-intercept? It could be x-intercept has the same meaning as the zeros of the function. So when I say x-intercept or zeros of the function, or when I say the solution of the function, all of them mean the same thing. So whether you were asked to find the x-intercept or they're asking you, oh, what are the zeros of this function? Or they're asking you, what is the solution of this function? All these, in other words, they are telling you that you need to find the x value, the x, which means y is 0. Does that only apply for quadratic functions? No. We can be asking about any of the functions. The first thing when you hear the word x-intercept or zeros of the function or solution of the function, you should automatically know that I have to set y equal to 0, or I have to set my output equal to 0, because as you know, your output is always your y, and you have to find the value of x. Now I can't remember if we have more terms or more words that we use, which means x-intercept, zeros, and solution. But we're going to stick to this for now. If there is more that I can remember of, I'm just going to add to it. All right. So I'm going to go ahead and start with example 1, but I feel it's very important for you to know why we do what we do, why we ask for x-intercept. When are we going to use that quadratic equation and solve it using the square root method? All right. So we're going to start with example 1. And, through the example, I'll be talking about these steps. So, example 1. What do I have for example 1? I'm going to start, of course, with the easiest thing, and then we're going to start adding up to it. All right, so I have x squared minus 1 equals 24. And the question is, solve the quadratic equation below, or find, you know what, let me do that. Let me say find the zeros of the function. That's a question mark. So what are the zeros? Or I have find, so I don't need a question mark. All right, so what does it mean when we say find the zeros? I automatically know that this has to be set equal to 0. So what we're going to do, I'm going to write it down. X squared minus 1 equals 24. And I will look and I will see, oh, I have x squared and I have a constant. I do not, so that is a quadratic function. I do not have an x value. So what does that mean? That means I can solve it by the square root method. So looking at this is just like I'm doing regular two-step equation. I'm going to add 1 on both sides because I want to get rid of this one on this side and take it to the other side. Crossed out. I got x squared equals 25. Now, the previous video we talked about what is an x squared and what is a square root of a number, right? So now, when we used to have, for example, I'm just going to put it here as an example. When we used to have 2x equals 10, we used to say, oh, for me to get rid of 2, I need to do the opposite, which is divide both sides with that coefficient, and I will get x equals 5. But in this case, I have x squared, x to the second power. What is the thing that will let me get rid of that second power? The only way I can get rid of that second power is by squaring both sides. So squaring both sides to get rid of the square or the exponent in x. So in order for me to get rid of that exponent in x, I need to square root both sides, because remember, square root, as we mentioned in the previous lesson, of a, so I have here 1, I have here 2, is the same as a, and 1 over 2 as my exponent. All right, so what do we have here? If I have x squared equal 25, and I'm gonna square root both sides. I got a square root here, and I got a square root here. So what's gonna happen, just like we said in yesterday's lesson, that square is gonna get rid of that radical. They're gonna cancel out, and I will have x. And as we also said, that the 25, it just happened to be a perfect square. So square root of 5 squared. X is that second power, and that square root are going to cross out. So we will have, when we cross out this and we have that x value, we always take two values. X might be positive 5, and x might be negative 5. So which means I will have two values for x. So we will have, well, there is more to it. Sometimes one of them is not going to work, and it's going to be called extraneous solution, but we're going to talk about this in a different lesson. So we have zeros, of the function. Remember, we always indicate them by x and y. They're going to be the first time 5 and 0, and they're going to be -5 and 0. Because we always take the positive and the negative value of the answer when we are getting rid of the square root. All right, so this is for this example. Now, you know, as I always do, I'd like to do the you try part. So let's go ahead and do the you try part. And again, try to pause the video, please. All right, so you try. And that is example 2. So what do we have here? We have 3x squared plus 7 equals 55. And of course, you know, my advice is for you to pause the video for 1 minute and try it. So again, the question is gonna be, what are the zeros of the function? So here, let me just keep the orange. What is or are the zeros of the function? All right. So hopefully you tried it on your own. Now let's check if you got the right answer. So we got 3x squared plus 7 equals 55. So I will ask myself this question. What does the word zeros mean? It means I'm looking for the value of x. That means y equal to 0. That means where does my graph, in this case it's a parabola, where does the parabola hit that x-axis? So I'm going to look and I'm going to, oh, I have to the second power and I don't have a value for x. So the best method that's going to work is the square root method. So the steps are to put all, here, let me just break it down just in case. So my goal always is to put all variables on one side, all variables on one side, equal to all constants on the other side. Does it matter which one goes first? No, it doesn't matter because this is an equal sign. If it's an equality, then it would have made a difference. An inequality means it's less than or greater than. Oh. All right, so let's see here. I'm going to write it again. 3x squared plus 7 is 55. So I'm going to take the 7 to the other side. So I'm going to subtract 7 on both sides. And I will get, this is going to be crossed out with that, 3x squared. Remember, you always have to drop down the equality sign is equal to 48. Now I'm not finished. I need to do, I have 3x squared. I am looking for x by itself. Before I find x squared, I need to get rid of 3 that is paired with x squared by doing the opposite. And what's the mathematical operation between 3 and x squared? They are multiplied. So in order for me to get rid of it, I need to divide the x squared. I'm sorry, the 3 and 3x squared. So get rid of the 3 that's paired with x squared by doing the opposite of multiplication. All right, so I'm gonna just write it again. I got 3x squared plus 7, equal 48. So we're going to go ahead and divide both sides by 3. And then we got x squared equal 48 over 3 is like a division, which is 16. So what do I have here? I have x squared, and I'm looking for x. But I know if I have anything to the second power, in order for me to get rid of that exponent, I can simply square root both sides. Why do we square root both sides? Why not one side? Because when we do something to one side, we have to do it to the other side so that we can keep our equation balanced. Otherwise, I will be just adding random stuff and it's not going to be a balanced equation anymore. So that's why when you do one to the one side, you have to do the same thing to the other side. Square root both sides to get rid of the exponent. So I'm going to do square root here and square root here. And as we learned from the previous lesson, the square root and the square are going to cross out. So I'm going to have x. And I know that 16, also I know that from the previous lesson, but we know that 16 is a perfect square. So it's square root of 4 squared. That square and that radical are going to go. But since this is a constant and I'm getting rid of the square, that means I'm going to have 2 values for x. The first time it's going to be a positive value. The second time it's going to be a negative value. Now, as I said, in future lessons, you will see that some of them are not going to be true. But in this case, I just want you to keep in mind that there will be nothing called extraneous solutions. However, you will see that in later lessons. So the zeros of the function, 4 and 0, and negative 4 and 0. So if you've done graphing, I'm just going to write it in a piece of paper because I don't want to keep it in here. So if you're talking about parabolas, let's say, that's what it means. It means maybe my parabola is like that. That means this is negative 4 and this is 4. And this is what we call the zeros or the roots or the solution of the function. All right? Or the x-intercept. So these are the values that we're looking for right now, are these ones in the parabola. This should be y and this should be x. I'm going to have a lesson on that. I know we covered this in class already, but I'm going to hopefully